So we move on to a slightly new topic here, equations. And the conversation of equations must start with the conversations about one of the most misunderstood symbols in algebra. And it's this symbol, equals. So why is this symbol so misunderstood? I'm going to show you by putting this up. Okay, on the calculator that you've come to know and love, what happens when you hit the equal sign button? Right? Almost every calculator has an equal sign. You do 3 times 7 and you hit equals. Well, it gives you the answer, right? Equals, the equal sign over time has come to be associated with calculate this, or makes, or give me the answer when I hit equals. Well, that's not the purpose of the equal sign. The equal sign is simply meant to show that this thing over here is the same thing as this thing over here, right? What you have here and what you have here are equal to each other. It doesn't necessarily mean that one thing must be the answer, but that's how it often gets put in our brains based on how textbooks sort of phrase certain questions. And so another thing that's important to consider with equal signs is truth. A statement that has an equal sign can be true or it can be false. For example, this is a true or false question. Is this true? Is that a true statement? No, 3 plus 1 does not equal 2 plus 4. That is absolutely a false statement. Well, what about this? What about 3 plus 1 equals 2 plus 2? Put a little question mark there. Is that true or is that false? Well, 3 plus 1 does equal 2 plus 2. They both equal 4, right? So that's a true statement. So when you have equal signs, you can have true statements and you can have false statements. And so what we're going to care about in solving equations is finding truth. You didn't expect math class to be so philosophical, did you? It is. So here is what our basic one-step equations will look like to start. Solve. And then you're going to have something that looks like this. X minus 3 equals 4. I'm going to give you a very specific definition of the word solve, right? What it means to solve an equation. And it means this. Find the value of the variable that makes the equation true. We just talked about truth. We want to find the value of the variable that makes that specific equation true. Because variables, as we're going to come to find out, can represent anything, right? Give me a number. Nobody's there in front of me, so you can't. I'm just going to pick a random number that I imagine somebody thought in their brain. 9. I'm just going to imagine the number 9. And generally, variables can represent any number. So I could write 9 minus 3 equals 4. But that's not a true statement, right? That is false. Other numbers. 0. Let's pretend, what if 0 is the value of x? 0 minus 3 equals 4. That's another false statement, right? And now I imagine somebody saying 7, say 7, right? 7 minus 3 is equal to 4. Well, that right there is a true statement, right? That right there is a true statement. And so in this case, the value that x had to be was 7. X had to be 7 in order for this equation to be true. Okay? So that's how I want you to think about solving equations. Finding the value of the variable that will make the equation true. And the way we start in this class is we have, it's very simple, where our equations are simply going to have one solution. There's only going to be one possible number that makes the equation true. As we advance, we're going to find that there will be more equations and other types of equations that can have multiple solutions, or the solutions even look a little bit different. So let's talk about now how to solve equations, because there's a specific process that you can go through to solve equations. You can just sometimes stare at them and figure it out, right? You might just be able to look at this and say, I know that 2 plus 3 equals 5, but they're going to get much more complex, so we want to have a process to follow. So the way I like to start these is imagining the equal sign and drawing a line, finding the equal sign and drawing a line. Write down that equal sign, because you know that whatever is on either side of that line has to be equal. And we can now follow a basic principle of mathematics that says if I do the same thing to both sides of an equation, it's still equal. It can be addition, it can be subtraction, it can be multiplication, it can be division, the equality property of addition, the equality property of multiplication. So I can do whatever I want as long as I do it to both sides. So I've got 2 plus some number equals 5. Well, my goal is to get a statement down here at the bottom that tells me x equals something. So I need to do some manipulation, some changing to get this x all by itself. We say we want to isolate, right? Get it by itself. We need to isolate the variable. On this side of the equation, I've got two things. I've got a 2 and I've got an x. I want the x to stay right where it is. It's the 2 that's the problem. I need to get rid of the 2. So how do we get rid of this 2? We subtract it. We want to get rid of it because it's x plus 2, so we're going to subtract the 2 from both sides. And now I'm going to add a little step in here that you might not have seen before. What is 2 minus 2? 0. Agreed? 2 minus 2 is 0. Plus x equals, and then what's 5 minus 2? It's 3. So notice how we did the same thing to both sides, right? Here's the line. I did minus 2 on either side. I simplified it, like I did the math. 5 minus 2 equals 3. 2 minus 2 equals 0. The x, we didn't change anything with the x. And now we have this statement of 0 plus x equals 3. We're always looking for ways to make our mathematical expression simpler. So, return back to a conversation we previously had about mathematical algebraic properties of addition. Does 0 plus x look familiar to you? If it doesn't, pause, go back to your notes. You might recognize it as the additive identity. Remember that one? Identity. Where you take a number, you add 0, and what do you get when you add 0 plus anything? You just get that number. 0 plus x is equal to x. So this thing right here can be simplified to just be x. X is equal to 3. Yeah, I know that was a lot to do in order to get to this solution. But this all has to be ingrained, right? You need to see the foundation, the why behind the reason we solve equations like we do. Are you going to have to show every single step there? No. I do want to see this stuff, right? This stuff is important, right? Knowing that you've got to subtract 2 from both sides. Okay, let's look at another one. So let's do this. 4 plus 7 equals x minus 8. My first question to you to consider when you pause this is, what's different about this one from the previous one? So stop and think about that. What you should notice is, if you find your equal sign, always start by finding the equal sign, is that the variable's on the right side instead of the left side, compared to the previous problem. 4 plus 7, there's actually some numbers over here on a single side that we can combine and add. It's also subtraction instead of addition. So what I would say is anytime you can clean something up and do it in an equation, just do it. 4 plus 7 is 11. That's totally fine to do. 11 is equal to x minus 8. Again, our goal is to isolate the variable. Get the variable all by itself. It doesn't matter which side it's on. We just want to get it by itself. The problem in this case is we've got this minus 8 over here. We want the minus 8 to go away so the x can be alone. How do we undo subtraction of 8? We add 8. We do the inverse operation. We want to think about, like the previous problem, what do we have to do to get this thing to turn into 0? 2 minus 2 gets us to 0. So what do we have to do to this minus 8 to get it to 0? We add 8. So we will do the opposite operation to both sides of the line, to both sides of the equation. Now we have 19 is equal to, this would be x plus 0, which is just x. And there is our solution, which of course we can check. That's the great thing about solving equations. You can always go back and say, hey, is this actually true? Is 4 plus 7 equal to 19 minus 8? Well, yeah, it sure is. Let's do another one. Let's say we have 3x is equal to 2 plus 10. So we always stare at our problem first. We analyze it, we examine it, we see what's going on, we notice things. I see a single variable. I see my equal sign. I'm immediately going to draw my line. I see stuff over here that can be added. I'm going to start by simplifying that, right? 2 plus 10 is 12. That makes the problem easier to look at right away. 3x. Remember, that means 3 times x. This problem's a little bit different. 3 times x equals 12. 3 times something equals 12. I'm going to put the dot in there just so I remember. Here we have multiplication. To undo multiplication, we divide. Division is the inverse operation to multiplication. So I want to make this 3 go away, and I do it by dividing both sides by 3. So I'm going to do both sides of the line, right? Divide by 3. Now I'm going to add in a little step, just like I did a couple problems ago. What's 3 divided by 3? 1. Now we have not 3x, but just 1x equals, do the division over here. 12 divided by 3 is 4. And now this should also look familiar to you. This thing right here. Whoops, that's not what I wanted. 1x. That should also look like a property that we've already talked about. Oh, my favorite name, the multiplicative identity. 1 times anything is simply itself. We can restate 1x as just x. And that gives us our solution of x equals 4. So we saw a couple examples where we were adding and subtracting. We saw an example here where we had to divide. The key is doing the opposite operation. So if it's addition, you subtract. If it's subtraction, you add. In this one, if it's multiplication, you divide. And you get the variable by itself. You do the same things to both sides. The goal is always finding the value of the variable that makes the equation true.